Hello class, this is the June 2010 geometry questions. So let us look at these questions together. Now here we have a diagram, and then we realize that these all three chords in fact are parallel to each other. Now which statement must be true? One thing that we get to realize is when the chords are parallel, the intersected arcs are also congruent. That's one thing that we get to realize. So then we have CE must be congruent to DF. In fact, that is true. Okay, there it goes. AC and DF, AC and DF, no, not really. And AC and CE, not. And then EF, which means this portion, and CD, not quite. So in fact, our answer will be number one only. Number two, negation basically means we have to embrace the word not, but this one already had not. That means double negation, therefore we will end up having I am going to eat ice cream. That would have been our answer, which is choice number two. Now here, which statement must be true? We have a pentagonal prism. Then let's try to look at one at a time. BC and ED. BC is right here. And then ED, which is way in the back. Since they're in the same plane, and then you will realize that since these two are not parallel, they will be meeting up somewhere if you extend them over here. So therefore, they are not parallel. Now, how about second one, FG and then CD? FG is right here. And then CD would have been right over there. In fact, yes, they will not meet up with one another, but in fact, they're not parallel either. In fact, we call these two lines as skewed line. So, of course, they're not parallel either. So FJ and then IH. FJ, which is this one, and IH. This looks somewhat familiar, such as the red one, the first choice. They're not going to be parallel. GB, which means this vertical line, and then HC, which is, this is another vertical line right here. We realize that these two are parallel. In fact, these are the opposite sides of a rectangle, which we know them to be parallel. Okay, there it goes. Our answer will be choice number 4. Now, here we have in an isosceles triangle. Notice that B is common. That means when we draw an isosceles triangle, here we have it. B must be on top. We have A, B, and then C like this. Where these two are equal to each other, that means these two base angles must be congruent to each other. Now, so which statement will always be true? Wait a minute. A and C, angle A and angle C being congruent to each other or equal to measures being equal to each other, that comes to be the first choice right here, choice number 3. All right, number 5. Here we have if this diagram below is reflected across the x-axis, that means this image will be located around here somewhere. Now, what will not be preserved? Now, then one thing that we get to realize is, let's look at slope AB. If AB was like this, then if you to reflect it about the x-axis, so since it was 3 units, I'm going to go for 3 units. 1, 2, 3. Here we have 8 units, so we're going to go down by 8 units. Right here. As you can see, this is if this one is a positive slope, this will be in fact end up being the negative slope. So slopes will not be the same. That means the slope of the line AB will not be preserved, or the other things will be. Therefore, all right, number 6, a right circular cylinder. Now then, let's try to get a cylinder here. Okay, so we have right circular cylinder. Now, altitude being equal to 11. Now, radius here is equal to 5. That means what is the lateral area? Lateral area meaning the area on the side. How do you find the lateral area? That will be in fact equal to 2 pi r, which will be the perimeter of the circle. But if you open this one up, it will be a rectangle, as we know, and multiply that by height. So that will be our lateral area. So when you look into this one, then we will end up getting 2 pi r becomes 5, and h becomes 11. In fact, our answer will become 110 pi. Now, if you have to calculate 110 pi, because we don't have them here, it seems, so we're going to plug that into calculator. 110 pi, right over here. Then, as you can see, that will be equal to 345. So it looks somewhat like this. So that becomes our final answer. All right, let us continue to number 7. Transversal intersects two lines, which condition would have always. So that means we have two lines that's given. We have no idea it will be parallel or not, but when you have vertical angles will always be congruent regardless. But alternate interior angles are congruent. For example, if you have this angle and this angle, if they're congruent to each other, then these two lines must be parallel. So therefore, our answer will be choice number 2. Number 8, if the diagonal of a quadrilateral do not bisect each other. If they were to bisect each other, it would be a parallelogram. But they do not bisect each other, then the quadrilateral could be. So in fact, if they were to bisect each other, it would have been the parallelogram. But since they do not, we have to get rid of all the parallelograms, which is this one. These three choices are the special parallelograms. So therefore, our answer would have been choice number 4. Trapezoid is the only one there, where the diagonals will not bisect each other. Now, number 9. What is the converse of the statement? Converse here, meaning we will switch the orders. So we have George gets the candy. If George gets the candy, that becomes the first one, and Bob does his homework will be the second. Oh, we see that right over here. When you switch the order between these two, that's called converse. All right, here it goes. We have 3 sides. Now, since it's kind of hard to tell, so we will try to put them together. So we have, let us say this is 8. That means PQ is somewhere around here, and then 12, let's call this one as 12. Then since Q is common, I'm going to put Q right here. That makes this one to be P. That makes this one to be R. And then you will realize that this must be 13. Now, which statement about the angles of the triangle must be true? Now, we realize that longer the side, bigger the angle is. The proof of this statement can be found in next year, algebra 2 trick, and then using the law of cosine. But for now, we're just going to use the observation. So here we have opposite of 13. Angle Q must be the biggest, which gives us choice 1 and choice 2. But by the same logic, opposite of side 8 must be the smallest angle, so therefore R must be the smallest, where Q must be the biggest, which means choice 1 will be our answer. All right, here we have, in which quadrant will the graph of the given equation intersect? So first thing is we just have to graph them, and then let's see what happens. All right, so y equals, we have 1/4 x minus 3. That's the first one. Second one is x squared plus 8x plus 12. Now, the best thing is if you have to go for zoom standard, number 6 right here, then that will be the linear line, and then there it goes. How about that? So as you can see, this will be the intersection on the third quadrant. So number 3 will be our answer. Now number 4, equilateral triangle, that means all three sides are equal to each other. So now when you do this one looks like this must be equal to that one, this one, because of the arch that you can see. And then it seems that this one must be measured from here, so it looks like number 1 seems to be our answer. Now number 2, only thing that they're saying is that this line seems to be passing through the, or simply perpendicular to its base. It doesn't mean that it's an equilateral triangle. This could possibly be an isosceles triangle. Now this one is simply measurement of one side. It doesn't tell us much. Here they're trying to simply get the perpendicular line from perpendicular line that passes through in the middle around here. So therefore our answer will be choice number 1. Addresses 3 sides are all being equal to each other. Number 13. Line segment AB is tangent to circle O at A. Now, which triangle is always formed in the point? Now, I think the best one is for us to draw something here. There it goes, circle O. But the segment is tangent, so we'll have a line that's tangent somewhere like this. And let us label each and every one. So here we have O. And then tangent at A. So that's A. Right over here. And this must be then B. Now, which type of triangle is always formed when points A, O, B are connected? Then we get to realize this is the radius and tangent. When radius and tangent comes together, one thing that we get to realize is they form right angle. Hence, we'll end up getting right triangle. Alright, here it goes. In fact, the equation of the circle becomes x minus h squared plus y minus k squared must be equal to r squared, given that h comma k is the center and r is the radius. Now, when you look into this one, center seems to be the origin, and then radius seems to be 1, 2, 3, 4. 4 seems to be the radius. So therefore, when you square the radius, we will end up getting 16. Choice number 4 would have been our answer. Number 15. Now, in fact, this in fact seems to be a very not so great question, because translation of 0, 0 will map this one to itself. Line reflection, in fact, line reflection, I mean, yeah, single one cannot do it, but the rotation of 180 can technically do this. So therefore, we have two possible answers: translation and rotation. So therefore, I'm just gonna mention that, and then I'm just gonna move on to the next question. Number 16, an isosceles trapezoid ABCD. Now then, here we have okay, so A, B, oops, they have to be equal to each other, so I'm just going to write them B over here. That makes this one to be C, and then this one to be D. Now, where AD is equal to 36, oh well, this AD has to be the bigger one, so then what I'm going to do is this. I'm just going to modify this one just a little bit. Alright, move A and D a little bit, and then B and C closer. Now, it looks better. This is 36. And then, AB is 17, and BC is 20. Now, what is the length of the altitude? Altitude, that means we're looking at that line segment. Why don't I call it H? Now, but when you look at the isosceles trapezoid, one good thing about this one is that when you cut both ends, where the middle portion will be equal to 20, but the whole thing must be 36. That makes each side to be another value. So 36 minus 20, which will be 16, but has to be separated into two locations, so each one will be equal to 8. The fact that we're going to find H, some of you guys might have remembered the special triple 8, 15, 17, so hence you can get the answer 15, but we'll just write up the Pythagorean theorem. 8 squared plus H squared will be equal to 17 squared. 8 squared is equal to 64 plus H squared, and then 17 squared would have been 289. When you subtract 64, H squared we'll realize that to be 225, where H will be equal to 15, which would have been right over here. Now, number 17, in plane P, the line M and N intersect at point A. If K is perpendicular to both lines at point P, then K is, so now here we realize once again, there's some sort of plane, and then line M and line M intersect at this point A. Now that means there's only one line that can be perpendicular to both. Now this one trying to be the 3D picture a little bit, but now we will realize that this must be perpendicular to M and also N. In fact, it will be perpendicular to the whole plane, so we'll end up getting choice 3 to be our answer. The next one. Here we have A, B, and then D is in this way. They look somewhat very similar to each other. Now, when you look into this one used to be 1, 4. Now we have 4, 1. Oh, wait a minute. Switching X and Y. In fact, we realize that that's possible if it is reflected through the Y equals X. Number 19. Now, what is the value of angle ABC? How do we find that angle? It will be simply the average between two outer arcs. 36 plus 20 divided by 2, that would have been our answer, which now realized 56 divided by 2, which is equal to 28. That would have been our final answer. Number 3. Number 20. We actually have done something like this in class. We realized that we're trying to make the perpendicular line here through line P. So, which statement demonstrated by this construction? So we have which statement demonstrates this construction? If a line parallel to a line that is perpendicular. Now we don't have another line that's parallel, so forget about number 1. The set of points equidistant from the endpoint of a line segment that is, okay, we're talking about that perpendicular bisector of the segment, but endpoint, if in case of a line, there's no endpoint. So now, choice 3, two lines are perpendicular if they are equidistant from the given point. That wasn't what they're talking about, but rather they want to include P. So two lines are perpendicular if they intersect to form a vertical line. In fact, our fourth one is not really it. The best answer here seems to be set of points equidistant from endpoints of a line segment. Here we have a line segment. If we call that portion to be the line segment, then choice 2 seems to be the best answer. Now, what is the length to the nearest tenth of the line segment joining here? So we're trying to find the slope. If you have to use the slope formula, here we have d is equal to square root of 146 minus negative 4. x2 minus x1 squared. And then we have 52 minus 2 squared. And here we have 150 squared plus 50 squared. Now, one thing which we can do is this. We could actually put them together. Then this becomes 22500 plus 2500. And then we can continue as in 2500. Then we realize that 2500 is the perfect square, which is a 50 times 50. So we end up getting 50 square root of 10. Oh, actually, they're looking for the decimals. So let's try to go for that. Square root of, actually 50 square root of 10. That seems to be that this one, choice number 4 would be our answer. Alright, what is the slope of the line perpendicular? So perpendicular, that means slope has been negative reciprocal. So we have 3, so negative, that means one of these two. Reciprocal, that means choice 2. Alright, so we have AE is equal to 4. And then AB is equal to 12. 12 is the whole length. And then DB is equal to 6. They're asking for what is OC. OC is the radius, so why don't we just call this one as R. Then the expression is, since this portion is 6, outer portion will be also equal to 6. So the relationship is outer times 12. The whole thing is equal to outer, which is 4, times the whole thing, which is, if this is R, this will be also equal to R. So we have 4 plus 2R. Then we realize here 72, which is equal to 16 plus 8R. By subtracting 16, we get to have 56 is equal to 8R. R will be equal to, therefore, 7. But yeah, that's exactly what they're looking for. 7 will be our answer. Alright, now here we have, if you realize that 13 is the hypotenuse of this right triangle, then one number that comes out most popular is 5, 12, 13 ratio. If you assume that, then you will realize that these two must be fitting into that Pythagorean triple. But let's try to do this one a bit longer way, which is the more traditional. We will try to do this one algebraically. So relationship goes x squared plus x plus 7 squared must be equal to 13 squared. So now here we have x squared plus x squared plus 14x. This is very important, the middle term, plus 49 is equal to 169. By subtracting 169, we get 2x squared plus 14x minus 120 is equal to 0. Now here, since 2 is common in all of them, what we can do is we can divide by 2, or we can factor out 2. So here we have x squared plus 16x minus 60 is equal to 0. Well, I meant 7 right here. So when you factor this one, we get to realize 2 and then x plus 12 times x minus 5 has to be equal to 0. That means here, from here, we get x must be equal to 5, or x must be equal to negative 12. But I'm sorry, negative 12 wouldn't work as the side of the triangle. So therefore, x being equal to 5. But they're looking for the base. How can we find the value of the base? Base is 2x. Since x equals 5, base 2x will be equal to 10. Choice number 2 would be the answer. Alright, now here we have, this one is angle bisector. This one is also an angle bisector. The fact that they're meeting up at a single point, that means the line BG will also be the angle bisector by the concurrency of the three angle bisectors. That means we're looking at that angle must be equal to that angle. ABG or DBG is equal to EBG. Alright, there it goes. Number 4 will be our answer. Alright, here we have two triangles, seems to be, and we realize that this angle must be equal to this angle because they share same arc, and then they also share another pair of angles, which is vertical angles. Now, then we get to realize that these are the triangles. Triangle ACE and then BDO must be simply similar. That will be BDE. So therefore, our answer will be choice number 2. All right, two lines are represented by the equation that's given. For which value of m will lines be parallel? So once again, two lines that parallel, that means slope here must be equal to slope that we get over here. So negative 1/2 y equals 6x plus 10. That means in order for us to get rid of negative 1/2, we will multiply both sides by negative 2. And negative 2 cancels out with negative 1/2. Y now becomes negative 12x minus 20. The slope is negative 12. That becomes our answer. All right, number 28. The coordinate of the vertices of the parallelograms are given. The slopes of the which line segments could be calculated to show that ABCD is rectangle. Now, to show that something is a rectangle from parallelogram, simply two consecutive sides has to be perpendicular. Now, then, arbitrarily, I'm just going to make up a rectangle. If I call this side as A, B, C, B. Now, AB and DC, AB and then DC, they're parallel, so it doesn't show that it's a right. You're gonna have the right angle. AB and BC, AB and then BC. That's one pair. We will realize that this angle will have given us values that only we can get having the right angle. Now, AB and then BC. Alright, so AB and BC are given right here. Choice number 2 would have been our answer. Now, number 29. Wooden sphere that has a diameter of 12. So that means, let's try to look into that. Alright, I'm hoping for some sort of sphere. Okay. Sphere, right, okay. So there it goes, we have sphere. Now, diameter is 12 inches, then from one side to another side, that would be equal to 12 inches. Now, find the surface area of the sphere. Surface area of the sphere is simply 4 pi r squared. Here r will be equal to 6, because diameter is equal to 12. That makes 4 times pi times 6 squared. Now, they want us to have it to the nearest square inch. That means so 4 pi r, here we get to realize it was a 6 square. Then that's equal to 452. Now, nearest square of an inch. So therefore, 389, but 452 seems to be this nearest square of an inch. All right. Number 30. Mid-segment, that means this must be equal to this one, and this must be equal to this one, where the small triangle and big triangle will be similar to 1 to 2 ratio, as you can see. DE is equal to 7. That automatically tells us that this must be 14. Now AB is equal to 10, and then BC is equal to 13. Then what is the perimeter of the triangle ABC? Oh, okay, we have everything that we need. We just have to add up these three values. Then we'll end up getting 37 becomes our final answer. Now number 31. The right triangle angle D is 90 degrees. So I will try to get the right triangle here. And then angle D would have been right here. Now angle F is 12 degrees less than twice of angle E. So let's call this one as F and E. And angle F will be 12 degrees less, so minus 12. Twice of E, so 2x, which makes this one to be equal to x. That means when we add up these two, they must be equal to 90 degrees. So there we have 2x minus 12 plus x must be equal to 90. By subtracting 12, we get 3x must be equal to 102. By dividing it by 3, x must be equal to then 34. Will be our answer. So now there it goes, 34. So x equals 34 degrees. All right, let's move on to number 32. We like to show that this triangle will be reflected over the line x equals 2. X equals 2, in fact, will be right over here. The vertical line, there we can just raise this one up this way. Now, state the coordinates of x prime, y prime, and z prime of the image of original triangle. So we have here, since y was 2 units away from the line, I'm going to go over 2 units. And this must be y prime. So z is 1, 2, 3, 4, 5 units away. So 1, 2, 3, 4, 5. That will be z prime. And y is 3 units away, so we're going to go for 1, 2, 3. X prime. That becomes its image. Now the coordinate, x becomes 2. In fact, x prime is 5, 1. Y prime seems to be 2, 4, 4. And z prime is, this one was 5, so 7, 4. There it goes. That's our answer, number 32. Number 33. Two lines, AB, and then those are 10 inches apart. Then sketch the locus of all points that are equidistant. That means we're looking at something in the middle somehow. Equidistance. And 7 inches from point R. See, the whole thing was 10 inches, then this must be 5 inches. And that's another 5 inches. We're looking for 7 inches from point R. That means we will have, now that will be 5 inches away because it hits the mid another line, but 7 inches is going to be a little bit bigger than that. So that's what we're going to have. Now, label X each point that satisfies both the conditions. So then that means we are looking at one number right here, X, and then the other one is one value and another value right here. Those are the two values. All right, number 34. The base of the pyramid is a rectangle. So we have some sort of a rectangle here. Now, width becomes 6 centimeters, and the length becomes 8. It's a little bit out of proportion, but it's okay. Find the height. If their volume is 288, then how are we going to find it? 6 times 8 times h must be equal to 288. Then when you multiply them, we get to realize that 48 h must be equal to 288. So when you divide 288 by 48, here we have 288 divided by 48. We get to realize 6 would have been our answer. Alright, now we found the height. But in centimeters, okay, let me just write down the centimeters. Number 35, now quadrilateral ABCD. Here we have AB and then CD. Seems to be opposite sides are congruent, and then AD and then BC are also congruent. That means in a quadrilateral, AB is congruent to CD, and then AD A, B, C, then AD must be congruent to BC. That tells us since opposite sides are equal to each other, this got to be a parallelogram. Now, diagonal BD is drawn. Now, then we need to prove that angle BDC. BDC. We need to somehow show that this angle BDC and ABD, they must be congruent. Now, if I were to just briefly say it in words, since this is a parallelogram because opposite sides are equal to each other, that means this line must be parallel to this one. Actually, not only that, this red line must be parallel to this red line, cut by a transversal, which creates two congruent alternate interior angles. Therefore, our answer will be done. Number 36. Find an equation of the line passing through this particular point and perpendicular to this one. Perpendicular, that means slopes are negative reciprocals. So slope 1 must be equal to negative reciprocals of the other slope. Then here we have what is the slope. By subtracting 3x, we get 2y must be equal to negative 3x plus 6. By dividing it by 2, y equals negative 3 over 2 x plus 3. But perpendicular, that means slope must be 2/3. Negation reciprocal 2/3. Now, that means from y equals mx, which is 2/3 x plus b format, you can just plug in 6, 5. And 5 equals 2 over 3 times 6 plus b. And here we realize that's equal to 4. So b must be equal to 1. That means our final equation is y equals 2/3 x plus 1. That seems to be our final answer. Alright, number 37. Now, write an equation whose diameter AB has endpoints -4, 2. So here, I'm just gonna so we have 4, 2. Oh, my bad. That's the -4, 2. That's A. Now, B is 4, 4. Alright, so these are the endpoints. That means write on equation. We need to find out the center. How can we find the center? Midpoint of those two. That means midpoint between -4, comma, oops, my bad, b has to be -4, so it has to be on the other side. Oops. Four, comma, -4, 2, 4. Now, and our midpoint, which ends up in the center, is the average of these two numbers. So between -4 and then 4, the average becomes 0. Add them up and divide by 2. 2 and -4, which will be -1, will be the center. That means using this one, 0 and then -1, which would have been right over here. So if I want to connect those values in this way, the vertical difference would be 3. Horizontal difference is, it should be actually 4. I think we moved the one step too further. So it should be 4, then 3, 4, and then this becomes 5. Becomes our answer. So once again, it should be 4 units to the left, not 5 as it is shown. So therefore, we get to realize 3, 4, 5. That means our final answer will be x squared, because it was a 0, plus y plus 1 squared, which is equal to 5 squared. That would have been our answer. We could write also 25 here. Now, number 38. Here we have it's a rhombus. Then we get to realize that this must be equal to this one. And then the next one is, since it's a parallelogram, diagonals bisect each other, so those two must be equal to each other. And finally, since this is a right triangle, when diagonals meet at a right angle, the other two angles besides the right angle must be complementary, meaning add up to 90. So let us try to look at the blue one first. That means 3x plus 30 must be equal to 8x minus 5. So when you subtract 3x from both sides and adding 5, then we get to have 35, which is equal to 8x. Or, my bad, 5x. Eight minus 3 becomes 5x. So divide by 5, x will be equal to 7. Very nice. Now let's go for green. Since diagonals are bisected in a special parallelogram also, we get to realize that 3z must be equal to 4z minus 8. Then by subtracting 4z, we get negative z is equal to negative 8, where z then is equal to 8. Positive 8. Now, we are looking at the red one. Since they're up to 90 degrees, so we have 5y minus 2 plus 9y plus 8. That must be equal to 14y plus 6, which ends up in 90. And by subtracting 6, we have 14y must be equal to 84. By dividing it by 14, we get to realize y must be equal to 6. But what they're looking for is SR. SR, that means we just have to plug in 7 in place of x. So here SR must be equal to 8 times 7 minus 5, which is equal to 51. Now, RT. RT would have been the whole length of the diagonal. Since z is equal to 8, we get to realize that 5z, which is 5 times 8, plus 5, talking about this one has to be doubled in order for us to get our answer. Now here we have 45 times 2, we end up getting 90, which is great. answer. Now the last one, since y is equal to 6, if you plug in TAS, that angle, when you plug that in, we get to realize that 9 times 9, 9 times 6 plus 8. That means we end up getting 54 plus 8, which is equal to 62. With that, we just finished. By the way, this is 2. June 2010 geometry questions. Thank you. Have a nice day.